Hi and welcome to my Physics 2212 Lab 2. The goals were to create two pieces of charged tape, then model that in GlowScript, and what I found was that the charges on the tape are 1.49 times 10 to the negative 8 coulombs, and the deficient electrons are 9.31 times 10 to the 10 electrons. The key concepts here are Newton's second law and the gravitational force near the surface of Earth. Another key concept is the E field from a rod with uniformly distributed charge, which is different from the last lab where it was only a point charge. The last key concept is Coulomb's law. Some key assumptions are that the charge is evenly distributed along the tape, air resistance is still being ignored, and that tapes generate the exact same amount of charge. Here's the procedure that was used to create both of the charged tapes. Here's a photo from the actual lab itself and my group mate doing the experiment. The key takeaway is that the tape and the pen moved toward each other, which meant that the tapes were positive because the pen is negative. The system is the floating U-tape, while the surroundings were the held U-tape and the Earth. Here are the measured values. Using Newton's second law, we can put the force from gravity and set it equal to the electric force, and then we can rearrange some variables using the E field formula from earlier to then calculate the charge, which came out to be 1.49 times e to the negative 8 coulombs. This is the computational model that I used, which modeled both tapes as lines of charges and added each contribution from the tiny little bit of each charge to then find the total E as well as the forces from each tape. Here's my model's output, which one thing to note is that the forces are, while they are incredibly similar, they are off by a pretty small factor, and that's just because of some potential error that came in from calculations or like measuring error or whatever. So the charges on the tape ended up being 1.49 times 10 to the negative 8 coulombs, so the deficient charges could be calculated by dividing that by the fundamental charge of an electron, which then gives me 9.31 times 10 to the 10 electrons. Just to note that the net force has to be 0 for the tape to float, which is how we got that whole Newton's second law thing. And then some potential sources of error are bad measurements, errors due to rounding, and then the U-tapes not being perfectly parallel with each other while we were measuring. The point charge model created a value of 6.6 times 10 to the negative 9 coulombs, while the line charge model had a charge of 1.49 times 10 to the negative 8 coulombs, and the difference is a factor of 2.26 times. The differences in the values are because we counted the charges as being distributed evenly across a rod rather than being clumped perfectly in the center of the tape. And the line charge would be closer to the real value because the model is closer to the actual tape rather than being a point charge model.